We are continuing with graphing other trig functions. Right now, something you should be aware of is you should be aware of a cosecant of theta graph is the same as saying 1 over the sine of theta. So these right here. This is the relationship of your cosecant graph. Now we're going to show you guys how I would like you to graph it. Let's say you didn't have a graphing calculator, you couldn't just type it in and hit graph and kind of copy it down. All right? What we're going to do is I want us to first graph this. I want us to graph the sine of theta plus 3. So I want you guys to graph this one first. So what would our midline be for the sine of theta plus 3? Right there. So y equals 3. So we're going to go right here. We're going to draw right here, carefully, right here where y is equal to 3, draw a nice straight line. Because I know most of you could probably do this with a graphing calculator. What if I took it away? What would happen? Right? Let's say the apocalypse happened. All graphing calculators were destroyed. Could you still graph this?
Yeah, we were fine.
Yes, you could, as long as you keep me alive. And so if you turn into a zombie, just make sure that the zombies don't eat Mr. DeMille. Right? Now, the next thing we're going to do is we're going to, what's the amplitude of this graph? What's the amplitude? 1, right? The amplitude's 1. So what I'm going to do right now is I'm going to go up from my midline and I'm going to draw another thin line, not a dark line, this thin line. I'm going to go down 1. So now I have where my sine graph is going to be between, okay? So I'm going to start graphing my sine graph. So right here, I'm going to start right here. That's where one of my points is going to be. I'm going to go right over here where there's a pi. Go right up here to another point. And one more right over here at 2 pi because the period of every single sine graph and cosine graph is 2 pi. Just like the period of any cosecant graph and secant graph is also 2 pi. Now, this sine graph is going to go all the way up, and right here at pi over 2, at pi over 2, it's going to get up to its highest point. And then right over here at 3 pi over 2, it's going to get at its lowest point. So now I'm going to make my little sketch. I'm going to go up, and down, and back up. Then over here, I'm going to continue the pattern at negative pi over 2. And it's going to get up to its highest point at negative 3 pi over 2. So right there, this graph right here between negative 2 pi and 2 pi is the sine of theta plus 3. Now, the next thing I want you guys to understand, where these points are on the midline of your sine of theta plus 3 graph, this is where the asymptotes are going to be for the cosecant of theta. So what I want you to do, wherever you guys see a point on your midline, I need you to draw an asymptote going straight up and down. So right here, right through 2 pi, right through pi. Draw in your asymptotes. This gives me my boundaries of where I'm going to draw my cosecant of theta graph. Now, every cosecant of theta graph, here's my final thing that I'm going to do. So I want you to understand, as the sine of graph goes like this, the cosecant of theta graph is going to share this point right here. And it's going to go up on either side, so it comes down. So this graph comes down touches that point and goes right back up. This one goes up, touches this point and goes right back down. So either it hits the highest point of the sine of theta graph or it hits the lowest point. This is the pattern I want you guys to be able to do without using a graphing calculator. If you see this graph, what do I want you to graph? I want you to graph this one first and then build your cosecant of theta graph. So now we're going to use a graphing calculator so you can see what we did. Okay, step by step. What did we do in our graphing calculator? So go to your graphing calculator. First thing we're going to do is we're going to change our windows. Okay, so let's change our windows. So we went from negative 2 pi to positive 2 pi. And we said our x scale was at a pi, not e, pi divided by 2. And our y minimum was a negative 2. Our y maximum was an 8. We look at our graph. Okay? So if you go over to y equals, I'm going to clear everything out. My y equals my previous class. And the first thing I wanted you to draw is I wanted you guys to draw your midline. So right here at y2, I'm going to type in, what was our midline? 3. So type in 3. And then I want you guys to type in the sine of x, close parentheses, plus 3. That's the very first thing I want you to do. And go ahead and hit graph after you do it, so you can see your sine of theta graph. We'll take a screenshot and go back to our picture. There's our picture. Here's our graph. There's the graph in the graphing calculator. Okay. Then what I'm going to do is I'm going to hit y equals. And go down to, I don't want to go to y3 because that's black. I want to go to purple. All right, so right here, purple y4, I want you guys to do 1 divided by the sine of x, close parentheses, plus 3. And when you guys do this, then you'll see how these graphs are connected. Watch where they connect when you hit graph. All right? That makes a heck of a lot more sense versus if I took away what? If I took away all this in the middle, some of you might like, well, why do they stop there? Why does it not go down lower or up higher? So you guys see how these are now connected. Can you see your asymptotes? Even though they're not drawn in, can you guys see your asymptotes right here? And what did we say our scale was for our x scale? They're all at what? Pi over 2. So right here, we're at 0. This right here is all the way over at pi. This right here is at 2 pi. So at pi, and at 2 pi, at negative pi, and at negative 2 pi, that's where all those asymptotes are. All right. So now you can go back and look at your graph. Does this graph match this graph? Sine of theta? Cosecant theta. All right. All right, so now that we have done that, what I'd like you to do, okay, we are going to build not a secant graph first. What are we going to build first? The midline, but we're going to, what's the inverse of the secant? Cosine. We're going to write cosine. We're going to write y equals cosine of theta over 3 plus pi minus 1. And yes, the very first thing that I would like you to do is I would like you to draw in the midline right here at this negative 1. So this is what I'm going to be looking for on your graph. Did you graph the midline? Did you graph the cosine of theta graph first? Okay. So what we're going to do is we are going to use the graphing calculator to help us with this cosine graph. All right, we're going to put all the points that we need to put on the cosine graph before we graph our secant graph. So right now, let's look at our boundaries here. We're going from negative 3 pi to positive 3 pi. This right here, this is going to be at 3 pi over a 4. So your x scale is going to be 3 pi over 4. So remember that. How did I get that? If this is 3 pi over 2, and this is 0, half of this, if I multiply this by a half, becomes 3 pi over 4. So remember that. So go to your window. We're going to go from negative 3 pi to positive 3 pi. You guys are going to make it the x scale at 3 pi divided by 4. The y minimum is at negative 4, and the y maximum is at positive 4. And the first thing we're going to do is we're going to hit y equals. We're going to clear out all of our sine graphs and cosecant graphs. And we're going to, very first thing we're going to type in right here at y2 is that negative 1, which is our midline. And up here, we're going to type in our graph, which is going to be the cosine of x divided by 3 plus pi, close parentheses, minus 1. So right now, when you hit graph, this is what I want you to graph. This is what I want you to sketch first. So I hit graph. This sketch right here is what I want you to transfer to your paper. We'll do it together. You guys see this point right here? This point right here? This point? And this point? And this point. This is where I'm going to be putting on the paper right here with you. Okay? So I'm starting right here. If you look at it, right here you're going to put a point. Right here at negative 3 pi over 2, you're going to put a point. Right here at 0, negative 2, you're going to put a point. 3 pi over 2, another point. And at 3 pi. And this is what I want you to carefully trace. Going down through here. And back up. I want everybody to have this graph, which is your y equals the cosine of theta divided by 3, blah, 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 yada, yada, yada. Draw that in nice and neat. Oh, wrong way. There we go. We're going from this to this. All right, after you guys have this sketched right here, what I want you to do is go to y equals, and now let's type in our graph, which is going to be not cosine, it's going to be 1 divided by cosine, which is the same as saying secant. And then just copy everything else. X divided by 3 plus pi, close, minus a 1, and then hit graph. Now, do you guys see where the asymptotes would be drawn? They would be drawn right here and right here. All right? So where are my asymptotes located on your paper? Where are they located if you look at it? 3 pi over 2 and negative 3 pi over 2. And notice, where do they cross through? Look at my midline. See my cosine graph? Right there. So look at the similarities. What happens? Right here on the midline, where this cosine graph touches our midline for our cosine graph, that's where your asymptotes are located. Look back at your sine. Where were the asymptotes located on your sine graph? Right there on the midline, right? So that's a pattern that will stay like that forever. Forever. Like, can't say the movie, you know, one of my French comedy acts, but who here has seen that movie right here? Forever. Thank you. You're late. That's okay. It's not going to be immortalized on YouTube or anything. It's not like a recording right now. Oh, whoops. All right, don't worry. I'm not going to call her out and say, Haley. come on, be on time or something like that. That would just be mean. So right now, draw on your asymptotes right here on your papers. I'm going to go back to my paper right here. I'm going to draw on my asymptotes right there. I was going to give us a nice yawn.
It's quiet,
It was fun. All right? And now what are you going to do? You're going to transfer what you see on your graphing calculator. This point right here, that graph is going like this. Then we're going to go up. It's going to hit that point right there and go back down. And last but not least, now obviously, if we were to widen our x minimum and x maximum, okay, if we were to widen it, can everybody see what this side would continue to do? It would continue to go up if we wanted it to, right? And over here on this side, it would also do the exact same thing if we widened it enough, okay? So we'd have to go over a little bit further for that to happen. But this is going to be your sketch right here. All right, we're about to do the final example right now. Okay, I'm going to zoom out real quick. We have 13, 14, 15, and 16. All right, 13 and 14 are dealing with tangent and cotangent. 15 and 16, secant and cosecant. There are different periods for different functions. So right now, I'm just going to let you guys know, I'm giving you a hint. The period for number 13, the period is going to be pi. The period for, formula is pi over b. The period for cotangent is also going to be pi over b. So when you're dealing with tangent and cotangent, this is going to be the formula that you're going to use to help you guys find your value for b in your tangent function or your cotangent function. So here's what you're going to write. Your final answer for number 13 will look like this. It will be a tangent, open parentheses, b theta minus c plus d. For cotangent, it would be y equals a cotangent, b theta minus c plus d. So this is what I'm looking for on 13 and 14. On 15 and 16, it's going to look a little different. I can go back if I need to. Right here for 15 and 16, when you're dealing with cosecant and secant, I want you to understand your period will be still 2 pi over b for both of these. So 2 pi over b will still be how you would deal with your period in finding your value for b. So what you've been doing with sine and cosine, same thing for secant and cosecant. All right? Now, there's the phase shift formula, just so you guys know, for all of them. The phase shift formula, thank God, is still just c divided by b. All right? So no matter which one you're working with, 13, 14, 15, or 16, for any of these graphs, the phase shift is still what? C over b. Okay? So how do I want you guys to write number 15? Y equals a secant b theta minus c plus d. Y equals a cosecant b theta minus c plus d. Okay? 14 has been chosen to be the example problem. All right, so like I said before, pi divided by b will always equal the value of the period for either a tangent or a cotangent function. So what I'm going to do right now is I'm going to say pi over b equals pi over 2 because it says our period is pi over 2. Now on this particular one, I'm not going to cross multiply because if pi, you guys agree that the value of pi is equal to the value of pi, then hopefully you will agree that my b value has to equal 2. So if pi equals pi, then this number has to be equal to this number. So right now, what do I know my b value has to be equal to? 2. All right. Since they don't mention the amplitude, just put your A value as 1. So automatically assume A is 1 if they don't mention anything about the amplitude. All right. Now, phase shift. Now some of you are like, why did you cross multiply? If I cross multiply, I'll do it really quickly. If I cross multiply, I get B times pi equals 2 pi. And when I divide both sides by pi, guess what I still get? I still get B equals 2. So right now I'm doing phase shift. Phase shift. Is there a formula for phase shift? Oops, not phase shift, sorry. Okay. Sorry there, Jim. Phase shift. So it's C over B. And our phase shift is equal to pi over 8. There's our phase shift. I'll change colors. So there's our phase shift, pi over 8. So I got my C value divided by my B value. I found my B value. Sorry, my B value is 2. Putting that equal to pi over 8. So now I'll cross multiply. Okay. And my cross products are 8 times C equals 2 times pi. We're going to divide both sides by 8, and C equals 2 pi over 8, but yes, that reduces, 2/8 reduces to 1/4, so I'm going to leave it as pi over 4. So right now, since I found my C value as pi over 4, I'm going to go over here, I'm going to write C equals pi over 4. And then the easiest one is my D value. Because my D value is whatever my vertical shift is. So if my vertical shift is 7, then I know my D value is equal to a 7. So we're just going to take these numbers right here. We're going to take these numbers, we're just going to plug them into our cotangent functions. Here's how I'm going to write. Y equals the cotangent of my D value is 2, so I'm going to write 2 theta, and put minus. I'm going to take my C value, which is pi over 4, and then I'm going to take my D value and put plus 7. What I'm doing right now is I'm following this pattern. Y equals A cotangent B theta minus C plus D. So my final answer for number 14, that right there. Really, all you have to really worry about, it's a little tricky, is dealing with what? Finding your, what are the two hardest things to find? Your B value and your C value. Those are the hardest. Okay? Right now, your A value for all these problems is just going to be 1. Your D value is going to be whatever the vertical shift is. You have to do a little what? A little ratio, right? A little proportion here, dealing with your period and your phase shift. And that's what you're working on.